Hey guys, welcome to our second molecular polarity video regarding chemistry, and today we're going to be focusing on nonpolar bonds. So nonpolar bonds, and you can see the definition over here, is where electrons are shared equally. And you might be wondering, well, that's the definition of a covalent bond. They're being shared. But notice how it says equally. And as we permeated last time, there were there are two types of covalent bonds: polar covalent bonds and nonpolar covalent bonds. Nonpolar covalent bonds are where electrons are shared equally, whereas polar covalent bonds are where electrons are shared unequally. Electrons were closer to one atom, or the more electronegative atom, compared to the other atom. But in nonpolar bonds, the distance of the electrons between both atoms is equal. So the electrons are equidistant to each atom. So let's draw an example here. Let's talk about O2. I'll come to this example later, but let's talk about O2. O2 has the chemical formula of O and O. And in this formula, O2 forms a double bond with the oxygen forms a double bond. So we see a double bond over here. And since 2 electrons are being taken out from both sides, we have 4 electrons left on each oxygen molecule. So we draw 1, 2, 1, 2. Let me zoom in. So 1, 2, 1, 2. So this oxygen now has its full octet because it's sharing 2 from this atom. It has 2 of its own over here, and it has 2 pairs of non-bonding electrons. And if you don't know what non-bonding pairs are, I strongly suggest you to refer back to our previous video, where we talked about molecular geometry and the shapes that molecules can take. So we have our full octet over here, and we can mirror this drawing and draw it over here. So now this oxygen 2 molecule is fully stable, and each molecule has a noble gas configuration. And we can determine that this is an electronegative. This is a nonpolar covalent bond over here by determining the electronegativities of each atom. So we have the electronegativity of oxygen is approximately 3.5. But when we find out the electronegativity of a molecule, we're finding the difference between the two electronegativities. So the electronegativity of this oxygen atom is 3.5, and the electronegativity of this oxygen atom is 3.5. Because electronegativity is a trait, and it remains the same for each atom. So 3.5 minus 3.5 is 0. Fun fact, atoms that can form molecules by using the same elements. So let me rephrase that. Basically, any element that can form a molecule with its own type of element. So basically, this is an example. O2 is an example. Oxygen is an element, and oxygen is composed of 2 oxygen molecules. So oxygen is a diatomic element because both elements can be formed within a molecule, and it still consists of the same elements. So oxygen is a diatomic element. So diatomic element is basically any molecule. Let me get a better definition for this. So diatomic elements is a molecule that consists of 2 of the same types of atoms. So in this O2 molecule, we have 2 of the same type of atoms, two oxygens, and that's why oxygen is a diatomic element. And we know that all diatomic elements form nonpolar covalent bonds with one another. So I just wanted to get that out there. And let's come up with another scenario of where a molecule is nonpolar. But in this case, we're going to be having polar bonds, but the molecule is going to be nonpolar. And let me restate this. I said it in the last video, but I'll just remind you guys again. So most times, if a molecule has polar bonds, the molecule will be polar. And it goes the same thing for nonpolar bonds. Most times, if a molecule is nonpolar, it will be nonpolar. But there are a few cases of where a nonpolar bond will be where molecules with nonpolar bonds can be polar, and but there are also a lot of scenarios where molecules with polar bonds can be nonpolar. So today I'm going to show you how a molecule with polar bonds can be nonpolar. So let's talk about carbon tetrachloride, or CCl4, and it's in this diagram over here. We see 4 chlorines and 1 carbon at the middle. So the carbon is the central atom and the chlorines are the terminal atoms. And in this diagram over here, you can see that it forms the tetrahedral shape. And now let's find out what bonds it creates. So the electronegativity of carbon is approximately 2.7, and the electronegativity of chlorine is approximately 3.2. So when we subtract these, we get 3.2 minus 2.7, we get 0.5. And let's refer back to our chart. So since it's 0.5, it's going to be a polar covalent bond. And since we're finding the bonds between carbon and chlorine, and there are 4 chlorine carbon bonds, we know that all of these bonds will be polar. So if we look at this diagram over here, we see that all of these bonds are polar. The carbon atom has a slightly positive charge, and the chlorine atoms have a slightly negative charge. So over here, you can see that there are arrows over here, and these arrows are called dipole arrows. And these dipole arrows point to the atoms that have the partially negative charge. So they just point to the most electronegative atom. So as you can see, they point to the most electronegative atom. But you can also determine that since all of these chlorine atoms have a partial negative charge, and therefore keep in mind that they're forming the same type of bond with the carbon, forgive me. They're forming the same carbon chlorine bond. Therefore, these charges, even though they're partial, the charges on every chlorine atom is going to be the same because it's the same type of element. So since they're the same type of charge, that means it's going to have the same pull on the electrons that are in the bond. And because of this, since these charges are coming from all around the atom, they're coming from opposite sides, from everywhere, they're being spread out equally, the charges, the pull on those electrons actually cancel out, and the molecule becomes nonpolar. So basically, these bonds are polar, but since these chlorine atoms have the same partial charge, their pull basically cancels out, and the molecule becomes nonpolar. And because of this, there is no net dipole movement. Therefore, there is no movement between the molecule. And this is a non-polar molecule. So thank you for watching this video, and this is a pretty hard topic to comprehend. So if you have any questions, please put it in the comments, and if you enjoy this YouTube video, please like and subscribe for more content. Thank you.